Okay, hello again. In this video, I will be discussing examples related to our previous video, which is the electric power and consumed energy. All right, so in this example, I will have a current of 5 ampere flows through a flashlight bulb when it is connected to 6 volt. What is the power of this bulb? Now, the way to answer this, well, I have the current, it is 5 ampere, and I have the voltage, it is 6 volt, and we are looking to find how much is the power. Well, we know from a previous scenario or previous video that the power could be IV, what could be I square multiplied with the resistance, or the voltage square divided by the resistance. But as you can see, we have only the current and the voltage, so our choice will be the first form. The power will be I times the voltage, that's 5 ampere multiplied by 6 volt, and that should give us 30 watt. Okay, so that's the electric power of this flashlight bulb. Okay, now let's move to another example. In this example here, what we have, how much energy in joules and in kilowatt hour is consumed by a 120 watt light bulb if it's left on for 15 minutes. Okay, so it's the same question. It's how much energy has been consumed or used by this light bulb for a certain time. But we need to do the calculation once in the ordinary unit of the energy, which is joule. And we're going to convert that to the energy unit or the electric energy unit kilowatt hour. So let's begin as a start. Well, we know the power, it is 120 watt, and the time is 15 minutes. Let's calculate how much energy. We said in our previous video the energy equal the power multiplied by time. Now, if I want to find the energy by using joule, I need to keep the power in watt, and the time need to be in seconds. So therefore, the power, it is in watt, has 120 watt. Now for the time, 15 minutes multiplied by 60, that will give us the value in seconds. Let's do the calculation. That should give us 108 10 to the power 3 joule. That is the energy of this light bulb if we keep it running for 15 minutes. All right, here on this side, I will try to calculate the consumed energy using kilowatt hour. It's the same formula. It's the power multiplied by the time, but this time we need it in kilowatt, and the time need to be converted to be in hours. So that should be simple. I can say it is 120 10 to the power minus 3. That's giving us kilowatt. And for the time, it is 15 minutes over 60 to make it that part of the hour. And to do the math, that will give us 0.035 kilowatt hour. That's the energy consumed of using this light bulb for this time. All right, let's go to maybe one more example related to the same idea. What I have here, how much energy in joules and kilowatt hour is consumed by a 200 watt stereo if it's left on for 4 hours. Okay, well, the same procedure we're gonna be using. I have the power, it is in 200 watt, and time here it is 4 hours. In previous example it was in minutes. So let's find the energy in joule. It is the power times multiplied by the time. The power, we keep it in watts, so it is 200. Now for the time we don't use hours because we need it in joule for the energy, so we have to convert the 4 hours into seconds. So 3600 multiplied by 4, that will give us that will give us about 2.88 10 to the power 6 joule. That's how much energy in joule for running this device. All right, let's do the consumed energy. That will be again the power multiplied with the time. The power must be converted to kilowatt, and the time we keep it in hour, which is already there, it is 4. That will give us 0.8 kilowatt hour. Okay, so I hope you managed to get the idea of these examples, that we have 3 different forms of calculating the electric power. It depends on what is given in the question. You will choose the correct formula. Then with these examples here, you've been asked to calculate the energy in joule and the consumed energy in kilowatt hour. So you know how to handle the flavor of these questions. One required watt with the seconds to make it in joule, but the other one required to make it a kilowatt hour to have the energy unit. Okay, I hope you find these examples useful, and in the next video I will solve examples related to the cost of using this energy. Thank you.